Hey guys, Joe Pye here at Advanced Innovations. Welcome back to my shop. I'm going to get back to the machining. It's like, holy mackerel, how long has it been, right? Now I'm going to start working on all this little U-joint stuff, and that is this assembly right in here. Gotta say, not digging the screw heads sticking out of those U-joints, it just doesn't look to scale to me. You know, that would be an enormous screw. So I'm going to change it up a little bit, and this part right here, which is supposed to be a ball, I'm going to make it a T across. And instead of using screws, I'm going to go press fit on that. Let's step over to the bench for a second and show you the logic, the mentality behind a rotating device like this, and what's going to press in and what's not. All right, off to the bench. All right, let's take a look at the logic behind pressing something together. Why does it work? How does it work? What do we do? Oh my goodness. Okay, here's the cleavage. Cleavage. Okay, Joe. What's on your mind there, brother? Cleave this. Cleavage. Scratch that. Anyway, the yoke. And the part in the middle. All the Sharpie markers I've stolen over my lifetime, and I still don't have any that are any good. There we go. That's a little closer, right? At least we can see that. Hole here. Hole here. And for all you guys that are going to say, that should be a dotted line, well, let's just say this is a section. Cut this in half. And the hole here. What's pressed in and what's not pressed in, because at the end of the day, something's got to be clearance and something has to be pressed. Well, for this application, I'm going to press it in the center. So this is the press fit zone, and this is the slip fit zone. Why, you say? Well, funny you should ask. Just imagine for just a second, or maybe a minute and 18 seconds, that the ends are pressed in and the center's the slip fit. What problem does that cause? Well, as you drive the pin in here, this starts to deflect. This starts to squeeze in. And as it passes through here, it enters here, and you apply more pressure, and you close the gap, and you press it in here, and all of a sudden, this is squeezed, and it's pinching this, and it doesn't spin like it's supposed to, and you start pulling your hair out and throwing things, and you get in trouble, and now you know why. Press fit in the center, slip fit on the ends. Or it could be a slip fit, and a press. Or the other way around, slip fit, press. Sounds like a dance move, right? This is just my choice. This may not be an industry standard. I know a lot of times you have bearing caps that are pressed onto regular universal joints that do basically the same thing, allow something to slip and something to press, but you got to have some press fit somewhere. So I'm going to go with press in the middle. It gives me the greatest length of engagement. And as far as the pins on the side are concerned, when my U-joint is complete, I'm going to have one continuous pin. Now, when I say continuous, get ready for this, guys. So we're talking small. Imperial, it's 312, 5/16, 8 millimeters, about 320. So that is really tiny. The one main pin will be full length, and the cross pins will stop, and they will butt against the pin in the center. And they will press onto the opposing clevis. All right, now that you're smarter, let's get over to the machine, make this guy right here. I'm going to start off with a piece of round stock. I am going to back bore 4 journals on it in an indexer. I am going to drill and ream through, and that should be just about it. I do have to establish a square profile on this though first, so let's start there. Off to the mill. There we go. The most accurate surfaces you can create to establish a square profile on the end of a part is to establish faces that are 180 degrees apart. The burrs on this piece are facing up, down, and forward. There are no burrs that will intersect where your anvil of your mic is going to set. So you see I just rotated that part 180 degrees. So there are no burrs on these faces that are going to interfere with that mic reading. Keep that in mind. The last thing you want to do is measure over top of a burr, and when you deburr the part, it's magically too small. After I put the square on, I did tram it to assure that I had center line dialed in on my digital readout. I've made the offset required to get to the center that I'm looking for, and now I'm just going to bring down a form tool and I'm going to plunge right on top of this. This is a 5/16 drill blank. First thing I did was grind it halfway through to center, and then I ground off the relief side very much like I would grind a tree pan tool until I had the width that I needed. Now off camera, prior to actually shooting this video a day or two ago, I made several test passes with this tool to assure that it was a plunge finish operation. I'm going to mark up the surface here. I'm going to go down about 35 thousandths, about a millimeter. If you go too deep, you're going to end up with flats on the round sections that you're trying to form. Do not go too deep. Okay, I'm going to run the tool down to a stop on the quill, bring the table up until I see a scratch, then raise the table and work from there. Ultimately, this piece will be parted off in the lathe to give me the backside surface, so I'm not really concerned with what I can access right now. But it's right down here in the corner. I don't know if it's even visible, but right where these two round journals come together. If you have any eminence right there, if you have any shred of a square, you can go a little bit deeper. But don't go too deep. You do not want to end up with flats on the sides of these rounds, because that would really spoil the look. I personally can't see it. I'm going to need an eye loupe to get in there and check it out. I may go a couple thousandths deeper. I'm about a tenth of a millimeter, 4 thousandths away from where I want to be. But you never know how the machine reacts, handles, stops, move, everything. Let's check it out. I don't know if you can see that. Hard to see through the camera, guys. I go a little deeper, but not much. I will take another pass. Let's do it. Now, for safety and for sake of not going past where I need to be, you can see that the bottom of my tool is not ground flat. It is ground this way. That way I can go to a very specific depth from the scratch and not risk hitting these little round journals that I'm making. Set exactly where I'm sitting right now on the table, I can now drill and ream the holes. For sake of linear alignment, I am going to drill and ream 2 holes entirely through the part at 90 degrees, ending up with 4, hopefully projecting through the boss on the opposite side. Let's do that. Okay, guys, for the drilling operation, it is very important that you drill all the way through from one side for each of these journals. If for some reason your indicator or your alignment of these bosses is off, then this boss will be left or right, and this boss will be left or right. So if you drill them, the holes will not be in line. I don't know if that makes any sense. Maybe I'll draw you a little picture, maybe I won't, but make sure that if you're going to do this, drill 2 holes, not 4. Okay, let's do it. All right, a quick look at the progress before we part this off. These pieces are very small, and a really good tip is to deburr them as much as you can while it's still connected to the bar. It's a whole lot easier to handle. And there you go. We'll part this off, we'll take another look at it. It's like, whoop, tiny little part. And a quick look after the parting operation. I did run these across 400 emery just to clean the cutter marks and the parting lines off the sides. And I made 3. I'll take the best 2 and away we go. Okay, let's move on to the mating half. Alright, before we get too far into this part, let's discuss the approach that I'm going to take. Now, looking at this print, this is somewhat confusing with all these lines and angles, and there are some things on here that just aren't possible the way it's drawn. So we're going to change a couple things up. Not change it up, but define it a little bit better. I'm going to start off with a standard piece of 5/16 diameter brass as the major diameter here. And I'm going to back turn a 45 onto it to the 250 diameter back here. So as it's sticking out of the chuck like this, I'll plunge into it with a tool, and I will sweep back until I hit the detail print number. Here we go. Of the 140. Now the 140 is across the top where the 45 bleeds out. So I'll plunge my tool in here and I'll walk it back until I establish the 140. And at that point, it go over to the mill. The 125 hole is already reamed into the part, so forgive me for not boring you with that detail. I'm going to just plunge the tool in the back, sweep it over. I'm going to make sure I have sufficient straight diameter that when I part it off, all is well. Same thing goes with the 125 hole that I drilled and reamed into it. It's drilled and reamed deep enough so that when I part it off, the hole is straight through. But I'm not going to part it off until the very end, just like many of the other pieces you've seen me do. I have to put a set screw, grub screw in here and do all the milling prior to that happening. All right, let's get over to the lathe, put this little cut on, and then drop it into the mill, finish it up. If you look carefully, you can see a very faint scribed line. It's a whole lot clearer to me than it is to you, but you can see it right at the tip of my fingernail. That is the 140 dimension that I want to hit. I want to neck it down in the back here to 250, so let's give that a shot. This tool is extremely sharp because it's normally used for 45-degree chamfering, not normally for turning. The phonographic finish that I'm getting here is unacceptable. I'm going to take a stone and just break the tip of that, and the finish should greatly improve. See if I'm right. Positioning the part in the indexer in the mill. Going to use an end mill with a 45-degree cut on the bottom of it to establish this 45-degree and this plane right here to the 120. I will do one side at a time, flip it over, and hopefully blend to the 140 tangent point where the chamfer ran out. Same dimension, okay? 120, profile of the end mill, straight across. Let's do it. Quick look at the cutter before we start. And the part. During this sequence, the table is set about 5 thousandths away from where the bottom plane is going to end up to give me the thickness of the protruding tab. I'm going to start walking the table in right now. That is an x-axis shift. I'm trying to get the 45-degree run out to be right on the edge of where that previous 45-degree was done on the lathe. So I'm taking a test cut and I'll rotate it just a little bit for visibility so I can see it with an eye loop. And I'm creeping in about 5 thousandths at a time. Now once I'm happy where the two planes meet, I will come up with the table and take all the little serration marks out of the finished thickness on the tab, just for a cosmetic finish. With the part of the same orientation that the two large flats were formed, I'm coming in here with an 093 cutter, and I'm going to hollow out the center here so that it accepts the small U-joint that I just produced earlier in this video. About a 2 thousandths clearance between these components should be sufficient. Now for this cross drilling operation, there is a very real possibility of bending these little brass ears, so you can put the hole in before you put the center slot in or use extremely sharp tools. But since the camera is right on there, close up like it is, see if you can pick up on the ears flexing during this cut. This is going to be a drilled hole because I want this to be a clearance hole for the pin, since the center pivoting section of this U-joint is the press. The outside holes are about 1,000 and a thousandth and a couple of tenths bigger than the pin itself. Let's do it. This is a 172 screw going in here. Major diameter about 72 thousandths. '74, '75 actually. I will rotate this piece 90 degrees from the way it is currently positioned and put some small chamfers on the face of this so it makes it easier to file. I could realistically use that same end mill that I used to do those flats since it has the 45 on it. But I'll throw in a dedicated 45-degree tool. Cut it this way, knock those corners off. And back to the lathe, part it off. Then I only have to do this 3 more times to complete that assembly. That is a very intricate little part of this machine. Okay, fresh out of the lathe, everything is parted off. These pieces actually do not go together. I mean, they fit, but at assembly, they are not intended to mate like this. These are components that will ultimately mate in a different direction with another part. But I just wanted to see if all the numbers, all the holes, everything, dimensions lined up. And I think it's a winner. Two more pieces to go, and I can call this one a done deal. All right, moving on to part number 12 and 36. This was the tube and universal section that I opted to make in one piece. If you watch the extended small cross-section milling video I posted a little while ago, these two guys are supposed to be drilled and pressed and silver soldered, but I'm going to make it in one piece. You've seen me do this part. It's exactly the same as these guys here with the exception of the hole, but I'm going to stick it out of the indexer a little bit farther, and I'm going to mill that on instead of using a tube and pressing it in and silver solder. So we'll pick up at the cross-section time for the milling. Let's do it. Okay, the back side of this particular piece is a little different than the other two that I just finished. I'm going to put that long, skinny, square stem on this so that it acts as the go-between, the telescopic inner tube of the joint assembly on the right side of the table. I'm going to use the same technique that I demonstrated a couple videos ago, so hang on, let's see what happens. I'm going to walk the cutter back and forth until I make contact with this diameter right here. I know my specified depth. I'm going to run it into the collet. I'm going to run it towards the collet, hopefully not into the collet. Poor choice of words there. Going to run it as far as I can without making contact with the shop tooling, which is always a good thing, especially when you're responsible for replacing it. Rotate it 90 degrees and do the same thing 3 times before I actually weaken this material and cut it off. Let's do it. Stop talking. God darn it. Do it. Little Sharpie marker on the surface of the part. I'm going to run it back and forth real quick and look for it to just clean up and leave me a little gold line. And when I see the gold line right there, I'm going to know that I am right where I need to be to go down the 93, I believe, to reach the final surface. I'm going to stay about 5 thousandths away on the depth of this cut and the X finish area to the back of the clevis. I will make my Z-axis final shift and run it all the way to the face of the collet. Rotate it 90 degrees. And do exactly the same thing, but I'm not going to go all the way through the part on this particular cut. So I have as much material as physically possible supporting this until the final operation. It's okay on the first side, but the second and third sides, let's not do that. And you don't need that remnant, so it's okay to knock it off. 2 sides complete. Coming around the front for this one. Halfway through the part. All the way to the collet. Back it back out. Up with the table 5. Shift 5 on the X. Face of the collet. Knock off the remnant. Getting close. Now this one here, you can't do rough and finish on this because it's just impossible. This is really flimsy. You'll see that in a second. That's a finish pass on the back of the part, and this is a finish pass for the length of the part. Knock the remnants off, call it a day. Well, I tell you, if that doesn't make you hold your breath, then there's just, you must be superhuman or something. Stand here the whole time holding my breath. The very last cut, you got a real danger of this thing tweaking and grabbing because there is literally nothing there. I mean, there is no support. And hopefully the sequence that I used, I did pick up some taper on the test pieces that I ran a couple weeks ago. So I ran, sorry about that. I ran double passes on 3 of the sides, and the 4th side, you just can't get away with that. So the 4th side is a full bite, full depth, right to the numbers kind of pass. I'm going to take this out of here and deburr this back edge here. There are no set screws, grub screws contained in this part because of how it functions. It is trapped between 2 stationary joints. I'll round off the nose here, deburr it, and I'll get back to you here in a second and show you what it looks like. Hopefully it fits. Fingers crossed. Real time, 16 minutes. Let's take a look at the finished components. Now, like I had said before, the plans did call out for this to be a tube pressed into this body, very much like the Big Brother here. Tube pressed into the body. This is the receiver feature. Telescopic U joint, and that is small. There it is. There's your thumbnail right there. Okay, more ways than one, right? All right, let's look at the other pieces. These are the pieces that will be assembled onto this. Bunch of small pins going on here, guys. A bunch of 16th inch diameter pins. Some going to be pressed. Actually, they're all going to be pressed. The ones going across the center are going to be 5/16 long, 8 millimeters ish. And the ones on the end are about 1.8 millimeters long. They're also going to be around 70 thou long ish. There is no way I'm going to be able to film that because it's going to be all tweezers and big fingers. So give me a second here. Let me put this all together. If all goes well. If all goes well, I'll be right back. Here we go. I think that, personally, my opinion, I think this looks better pinned than with large screws hanging out of that. It just looks more realistic. This is a little bit tougher to do as far as pinning is concerned, and I think it has a little bit more integrity. This is telescopic now, which is awesome. It's got a lot of range, about 3/4 of an inch of range, almost 20 millimeters worth of stretch. Now this is going to go between, let's see, pull this guy in. The table's going to sit on the front of the mill here, and the linkage is going to go between this back pulley and the table. So as the table goes up and down and left and right, you're going to need some type of leeway in here so that the linkages can stay connected to the respective points. So this one will get connected back here, this one will go to the table. Sit this on a V-block for a second and spin it, see what it looks like. That's an awful lot of work, guys. Get ready for that one. Well, I gotta say, I really wasn't looking forward to doing this, probably as much as I was looking forward to doing this, if that makes any sense whatsoever, which it probably doesn't. But I do thank you for hanging in, and I enjoyed this one. This was a nice piece. It's going to look good on the model, and I can't wait to see this model done for me and for you. So wherever you are in the world, I hope you're well, happy, and safe, all the above. Me, I am Joel Pye at Advanced Innovations in Austin, Texas. I'm out.